Toward the latter stages of World War II, airplane attacks on naval vessels motivated the U.S. Navy to develop a guided missile that could intercept aircraft beyond the range of gunfire. Although the number of vessels sunk by air-based assaults was small, the damage inflicted on ships, the loss of life, and the number of wounded servicemen were significant. As a result, a joint effort between Navy teams, government agencies, and private industry began intensive research and development in guided propulsion and supersonic aerodynamics, with the goal of creating a practical frontline layer of missile defense. Called Operation Bumblebee, the main objective was to research and develop guided missile technology and develop and deliver a surface-to-air missile system to the fleet.
So the question was, could the ships defend themselves? And we found we had to have much faster missiles and capability than we had in the guns that were prevalent in World War II time.
Although a few primitive surface-to-air missiles were available, space and safety concerns limited the ability to deploy a small, long-range rocket over long distances. Operation Bumblebee's initial work led to the development of the first U.S. naval surface-to-air missile, the Talos. The Talos was a large, long-range, ramjet-powered missile with a separating solid rocket booster. Talos entered service in 1958, but saw limited use due to its large size.
A Talos missile was extremely long and extremely heavy compared to everything else. That size of a launcher required to handle that big of a missile would only fit on real live, no kidding, World War II cruisers. The new design cruisers in those days weren't big enough to handle the Talos.
During the Vietnam War, Talos was used to eliminate radar sites and intercepted several North Vietnamese planes. Talos was last launched in 1979, and the remaining supplies of Talos, renamed the Vandal, were used as anti-ship missile target drones until 2005. During the initial development of Talos, a test vehicle was developed to evaluate control and guidance systems. This test vehicle performed so well, the Operation Bumblebee team decided to put it into service. This smaller two-stage medium-range missile was called Terrier and was the first surface-to-air guided missile deployed on Navy ships. The Terrier employed a beam-riding guidance system and used wings for flight control. The Terrier provided a medium-range, surface-to-air missile solution for smaller ships that could not accommodate the larger Talos. The Navy needed a facility dedicated to the engineering and production of missiles specifically for fleet use. In 1952, the Navy opened its first guided missile production facility in Pomona, California. The 140-acre Navy Industrial Reserve Ordnance Plant was owned by the Navy and operated by Convair.
The Navy lived right there. We knew who we were building missiles for because we had naval officers in uniform in our plant. The Navy liked to control the logistics of their ordnance, starting at the plant that built it, starting at the depot where the final assembly was done, and then on board ship.
The Pomona plant was bought by General Dynamics shortly after the facility opened. The Terrier's first test ship launch was in 1953 aboard the USS Mississippi, and the Terrier was later deployed for duty on the USS Boston in 1956.
A glimpse of the Navy of tomorrow, the USS Boston, America's first guided missile cruiser in action off Cuba. From below deck magazines, its potent Terrier missiles are automatically positioned on launching racks. Ship and missile were designed for each other in what engineers call an integrated weapons system.
The initial versions of the Terrier were not as effective against fast-moving, highly maneuverable fighters. Guidance and propulsion enhancements were combined with a shift from wing control to tail control to improve missile effectiveness. The tail control, when combined with dorsal fins, allowed the missile to have better flight and maneuvering characteristics than the attacking aircraft.
In other words, you had the same wings as an aircraft, you'd have the same limits on maneuverability. And because you wanted the missile to be able to intercept that aircraft, you had to have higher maneuverability. So the tail control allowed you to do that.
It also fit the launcher better because they could fold up and you had a nice package that went down in the hole, and then when it came up, when the missile came up, then the tail fins flopped out. All right. So it was a matter also of how many missiles could they get in a given space in the magazine. Because when you run out of bullets, you either got to get them transferred at sea, or you got to go back into home port and get them put in. You don't fight a war that way. You fight a war with what you got when the war is happening.
Although there have been some changes and modifications over the years, the tail fin control concept is still being used today. Further changes to the Terrier's guidance system and propulsion resulted in a new missile, the Tartar, which was developed in the early 1960s. The Terrier had a greater range capability, while the Tartar was smaller and could be used on destroyer-sized ships. All three missiles produced by Operation Bumblebee, the Talos, Terrier, and Tartar, offered a layered approach to air defense. The missiles were miniature wonders powered by vacuum tube electronics, gas generator-powered hydraulic and electrical power units, and radar-based proximity fuses. Terrier and Tartar's vacuum tubes required extensive warm-up time before they could be fired.
So if you had a threat coming, you'd have to fire the missile, turn the missile on, provide ship power to warm up the missile before you could launch it. So you had 20 to 30 seconds of warm-up time before you could launch the missile. The idea of Standard Missile 1 being all solid state was to allow you to have instantaneous reaction.
Technological advances in solid-state electronics, the availability of transistors, decommissioning of some ships, and the emerging threat of anti-ship missiles justified changes to the Terrier and Tartar missiles. The goal was to produce a medium and long-range missile that minimized compatibility changes and had a standard design that made future upgrades and repairs easier and more cost-effective. The Navy also wanted a missile that combined high performance with short reaction time, possessed inherent countermeasure capabilities, and was readily available for rapid deployment. As a result, the Terrier missile became the Standard Missile 1 extended range, while the Tartar missile became the Standard Missile 1 medium range.
You know, the whole notion of Standard Missile became clear over a period of time that what we were actually doing, we're making changes to the seeker and to the warhead and propulsion and other aspects that applied across the different missiles that had different range and different performance capabilities, but we were able to capitalize on those developments and apply it to more than one missile.
The SM-1 went into production in 1967, and various block changes and improvements made the SM-1 a proven deterrent against air and cruise missile threats. International countries began investing in Standard Missile as a surface-to-air ship defense weapon for their own fleets.
You know, when you have a system like Standard Missile, which becomes and has the reputation of being the premier air defense system in the U.S. Navy, everybody wants it.
Another concept unique to Standard Missile was that the missile would no longer require testing once the missile was delivered to the ship.
They were loaded on the ship, stayed on the ship, and every 2 years or so they would cycle back to the depot, come off of the ship. The depot would retest them. If they're still good, they'd go back on the ship and be shipped out again. But there was no testing on the ship required.
It's important in several ways. Number one, it reduces the manning that I have to have on the ships. As I reduce the number of people I have to have on ship, I reduce the life cycle cost of keeping that system out there. I also save the time I have to bring that missile up on the rail.
In the late 1960s, low-flying anti-ship missiles began to emerge as a threat to naval forces. An updated version of the Standard Missile was proposed that would combine high performance, short reaction time, and increased availability.
Standard Missile 1 was called a home all the way missile. And home all the way meant that you launched the missile at your target and it had to acquire the target within about 3 seconds or you wouldn't have a successful intercept. So once you acquired the target, then the missile would home continuously throughout flight until intercept.
Changes were also needed to create a missile that would be compatible with the older ships still using the Tartar and Terrier, yet still compatible with the soon-to-be-released Aegis-class warships.
The Aegis story is really a case study of how to do it right in weapon system development. Because the weapon system development is the ship, it's the radars, it's the illuminators, it's the CIC in the missile, and you cannot separate them. And in fact, in Aegis, even the countermeasure systems were integrated into that.
When Aegis came about, it was a total system. And this was a radical change from how things had been developed in the past, because they actually designed a ship and a radar and a missile as one entity. The intent was to have a total system. Prior to the Aegis program, one group would manage the shipbuilding would be done by one group, another group would do the radar development, and another group would do the missile. And trying to integrate those together was pretty difficult.
The updated integrated missile, called Standard Missile 2, used a monopulse receiver and mid-course guidance so the target could be acquired after launch. The new variant doubled the range, doubled the altitude, and allowed simultaneous control of multiple missiles in flight.
And if you go back and look at history, in all of the versions of Standard Missile, we have a tendency to make a significant guidance improvement in one generation, and then the next generation will start improving propulsion, and then the next time you go back and improve the guidance and then improve the propulsion, so that you keep gaining capability with each step.
The SM-2 was also fully integrated into the new Mark 41 vertical launcher.
To go off of a rail, this rail has got to move. It's analog, it's complex, you got motors, and you got to bring the missile up, you got to put it on the rail, it's got to move, it's got a slew. The vertical launch, you're on the launcher, you're ready to go. And so reaction time is much quicker.
The SM-2 was tested in the late 1970s and deployed on the first Aegis warship in 1983. The Terrier and Tartar concepts evolved to meet the threat. Tartar became the SM-2 medium range and was integrated into the Aegis warship design, while the Terrier became the SM-2 extended range, improving the capability of the fleet. Commonality has been the key throughout the life of the Standard Missile. Commonality of critical components from one generation to the next, commonality amongst interfaces for radar and launching systems, and commonality in engineering expertise, technical data, and logistic support. As a result, incremental upgrades have built on existing resources and upgrades to lower costs.
Even way back when, in the early 50s, we had a 13.5-inch airframe. Ships were built around using missiles that had 13.5-inch diameter. So to change the diameter of a missile, particularly bigger, it might be easier to get smaller, but particularly bigger, really costs the Navy, hence us the taxpayer, a lot of money.
You could mix and match any section to build a missile. So it didn't require, a match set of anything to build a missile. If you had a guidance section failure on a missile, take the guidance section off, put a new guidance section on, and you're right back in business.
My fellow Americans, thank you for sharing your time with me tonight. The subject I want to discuss with you, peace and national security.
In 1983, President Ronald Reagan presented a plan to use ground and space-based systems to protect the United States from nuclear ballistic missile attacks. Initially called the Strategic Defense Initiative, the name and mission of the organization shifted over the next decade to emphasize regional theater missile defense. Changes were also taking place within the walls of the missile maker. Standard Missile had been owned and built by General Dynamics since shortly after the Operation Bumblebee days. Hughes Missile Systems purchased General Dynamics in 1992. When the Navy required a second source contractor for the production of Standard Missile, Raytheon was brought on as a second source. Hughes and Raytheon formed a joint venture called the Standard Missile Company. Hughes was eventually sold to Raytheon making Raytheon the sole contractor of the Standard Missile.
And you know, everything doesn't go exactly the way you'd hoped it to, but I think for the time that it was developed, it probably met the need for the time. I think it had about a 3-year lifespan, and one of the good things about it was it did keep a lot of the key people involved in the program.
Emerging through the changes and mergers was the lightweight exoatmospheric projectile, or LEAP program.
Terrier LEAP was developed as a demonstration phase only. It was designed to show that the Navy could put a weapon system and a missile together that could hit things in outer space.
Engineers and scientists modified a Terrier extended-range missile to test if the large propulsion system of the missile would be stable enough to enter the exoatmospheric reaches of space.
We had a small team of really unbelievably talented engineers that were thinking out of the box, that were inventing ways to do things, that were piecing together and integrating fundamentally a weapon system, including the missile and the interceptor and the kill vehicle. It was very challenging because the ship that we were planning to do the intercept launches out of was scheduled to be decommissioned. And so you had a finite end date, and you knew that that end date wasn't going to be changed, it wasn't going to go away. And you had to get your missions and your flight tests off in a finite amount of time, and we were successful at doing all of that.
And so we had the Terrier missiles, and we knew what range they could do and how far they could do. We had the ship systems that could detect and track to an extent. And then at that time, the Ballistic Missile Defense Organization, BIMDO, was developing these lightweight kill vehicles that were, impact to kill, and we put those systems, the ship system, the missile, and the kill vehicle together, and did a number of early experiments that showed we could not only detect and track, we could launch successfully, the missile could fly out, and we could intercept and do a hit-to-kill kill of the incoming ballistic missile.
The ability to target threats in space showed that ships at sea were a valuable asset in the defense against ballistic missiles.
The focus for what was MDA in those days was the ground-based missile system, the long-range ICBM killer, Patriot, improved Patriot, and THAAD. The Navy came along and we showed that we could play in that same theater.
Well, ships have the luxury of being extremely mobile and not having to ask for permission to be there. And so you generally can position yourselves in a tactically suitable location from a ship to be able to defend almost any landmass.
The success of the Terrier LEAP program led to a new development follow-on program, which eventually became Standard Missile 3. Standard Missile has transitioned through block changes and provides an affordable, high-performing deterrent against a wide range of threats. The Standard Missile 3 is deployed on U.S. Navy and Japanese ships and is a key component in the United States' phased adaptive approach for missile defense in Europe. SM-3 was also used to eliminate a faulty satellite in space. The next generation of Standard Missile, the SM-6, has already been selected to provide sea-based terminal defense against ballistic threats. The fleets of the Navy and our allies can deploy rapidly, move anywhere, and concentrate enormous power anywhere on the globe. Standard Missile's continuous improvement enables fleet defense against a wide range of threats and has become a potent deterrent. The legacy of Standard Missile can be found in the people who have worked on the program over the past 60 years.
In any development program, there's always setbacks. There's always issues, unknown unknowns that you find out. And you got to resolve them. And it's the teamwork that allows us to resolve them in Standard Missile. It's that integrated team of government folk, field activity folk, prime and subcontractor folk that gets us to resolve those issues and get those things back out to the fleet where they belong.
I feel like there's a part of me in just about every Standard Missile that's out there. At least it feels that way to me, and of course I bleed Standard Missile blood as well. So
Standard Missile has been a win-win-win. A win for the fleet in that it gets more capability, A win for the government in that it gets more capability at lower cost, and a win for industry because it's able to focus its attention and its development efforts and make significant progress in these small incremental steps.
So I have a proud legacy in the people that made a tremendous contribution to this country that may or may not ever be known.
The ability to provide protection against attacking aircraft and modern-day threats is what keeps Raytheon, the U.S. Navy, the Missile Defense Agency, and our allies uniquely positioned to provide the finest fleet and national defense for another 60 years.